So for question 30, they give us a function, a reciprocal function, and then they ask us to find the vertical and horizontal asymptotes for this function. So we can use our idea from topic 5, where vertical asymptote is finding the domain for the x where it's not defined. Meanwhile, for horizontal asymptote, we have to find the limit from infinity for x approaches infinity. So for finding our vertical asymptote, okay, so we define our x first. For reciprocal function, or we call it rational function, fx is not defined when the denominator equals to 0. So means at that place we will have a vertical asymptote there. So when our denominator equals to 0, it will be undefined. So it will be occur a asymptote there, vertical asymptote. So what is the vertical asymptote? We try to factorize here. It will be x minus 2, x plus 2. So our x, which will make our function undefined, will be 2 and negative 2. So we can see there is a lot of marks here. So it is not enough. We just prove by using the idea from topic 5 function. So we have to prove it using the idea of limit. So when we want to do our idea of limit, we will let our limit when x approaches 2, because we have two x value here, which will make our function not defined. So we will try to see what happens when x approaches 2 from the left hand side for our function. And another idea will be limit x approaches 2 from the right hand side. So you can notice that when I substitute the value of 2 inside the function here, when we try to approximate our limit x 2, value at 2, so when we substitute here, we get 2 square. At numerator part is a value, but for denominator part it will be a 0. So the value here will be 10. So 10 over 0, automatically it will become undefined, which is infinity. So when x approaches 2 from the left hand side, okay, so when x approaches 2 from the left hand side, means our value is closer to 1.999. So when we test our value x equals to 1.999, our denominator part here, our approaching value 0 here, it will closer to left hand side. So left hand side it will become negative. It will be 1.999 square minus 4. So it will be in the characteristic of negative. So this one 10 over 0, we will get infinity. So in the characteristic of negative infinity, because what we get 0 here is from the left hand side. So it will be approximate close to 0, but it is not equal to 0. It's 0 from the left hand side. So we can repeat again for this. If we doing our value limit for x approaches 2 from the right hand side, when we substitute our value inside, they definitely will approximate to this 0, 10 over 0. But if we see the approximation value here, they were taking x approaches 2 to the right hand side, means 2 is close to the value of 2 from the right hand side. So our test value here is 0, x equals to 2.001. So what they create here, when they're near to the value of 0 here, it will be create a positive, a value that closer to 0 but is a positive properties. So this will get you a positive infinity. So this is a signal of us to see when we get a limit at a point, we get the answer of infinity. means our x equals to 2 is a asymptote, is a vertical asymptote. So we have another value to test here. So we continue for another value. So we will do for limit for x approaches another value is negative 2 from the left hand side. For our function, x squared minus 4. So you try to substitute. It will achieve a value close to the 0, and then value numerator is 10. So this will give you infinity. So in what kind of properties that will give you when you're getting x approaches negative 2 from the left hand side, means your x approaches value will be negative 0.2001, the closer value. So what we create here, when we approaches this value for this function, our 0 here, when we substitute here, our 0 here will definitely more than 4. So when it minus 4, it will be positive side. So this is a positive infinity. And then limit from x approaches negative 2 from the right hand side. So we'll get a value over 0. So value over 0 is infinity. Then we define what is the properties of this 0. When you have x approaches 2 from the negative 2 from the right hand side, means our value close to negative 2 from the right hand side, it will be negative 1.999 something. So our 0 here, so when I substitute x squared minus 4, it definitely will less than 4. So when it minus, it definitely is a negative properties, come to the 0, close to the value of 0 from the left hand side, and then our answer will be negative infinity. So from this result, we can conclude out that our vertical asymptote are x equals to 2 and x equals to negative 2. Okay, so we continue for horizontal asymptote. So for horizontal asymptote, we need to find it by using the idea limit approaches x to infinity for our function. So the result that we get, it will be our horizontal asymptote. So we try to substitute our x. Our first attempt always substitute the x here. So infinity over infinity, we get IDF. In order to simplify the IDF, we will going to divide the highest power. From the denominator here, it will be x squared. So we will divide every term of it by x squared. And we simplify our function. Then we try to substitute our limit at infinity again. So when we substitute our infinity here, we will notice that 2 over infinity, it will be 0. And then 1 minus infinity is also 0. So answer is 2. So when the answer comes, it is equals to 2. That will be our horizontal asymptote. So same process, we will go for limit at negative infinity. So limit at negative infinity for our function. We will take our simplified function, because when we put a negative infinity, it will similar to this case. So it also undergo the same process, which is divide the highest power of denominator. So I will take this function that already simplified. Then when we substitute our x equals to negative infinity here, it will be 2 over 1. 2 plus 0 over 1 minus 0. So it is equal to 2. So from here, we can conclude out our horizontal asymptote. It will be y equals to 2. So the value that we get here, the answer that we get here, it will be our horizontal asymptote. Okay, so when we get a undefined, a number divided a 0, undefined, so the x approaches the value here is our vertical asymptote. So vertical asymptote x equals to something. Horizontal asymptote y equals to something. So this is how we get our 8 marks. So you can see our concept. So the first concept, we must know where's our x value that will make our function undefined. So this is our basic from our topic 5. Then we're going to do our concept finding the limit for x approaches the value from left hand side and right hand side. So for both of them, and then to getting the answer. So another value will be -2 and get to the answer. So write down our vertical asymptote is -2 and 2. Another part will be our limit at infinity in order to find our horizontal asymptote. So that will be our concept, finding our limit at infinity for our function. And then simplify our function because it is IDF. Then to get to the answer. And then make the sentence come up with horizontal asymptote is y equals to 2. So using our information and our answer here, we are going to question B, which is sketching our graph. Alright, so we already know our vertical asymptote is this and horizontal asymptote is y equals to 2. So we set up our graph first. So for our x-axis, and then this is our y-axis. We have two vertical asymptote, which is -2 and +2. So when we draw our graph, make sure we label straight away x equals to -2, x equals to 2. This is our vertical asymptote. And then horizontal asymptote is y equals to 2. So horizontal asymptote y equals to 2. So this is our information from the part A. Then we see our result. When our graph approaches negative infinity, okay, negative infinity means left hand side, positive infinity means here right hand side. So you see, when our graph approaches negative infinity, our graph will be approaches to the value of 2. So means that it will come to the close to this line. So whether it is under or up here, we haven't decided yet, but we know our graph will come to the asymptote here, which is y equals to 2. And then we move to the closer part when we see our graph when x approaches -2 from the left hand side. So the limit when x approaches -2 from the left hand side, we get positive infinity. Positive infinity means up here. Up here. So it will clearly that our graph will be in the part above y equals to 2. So our graph will be like this. When graph approaches negative infinity, it close to the y equals to 2. When the graph approaches -2 from the left hand side, it goes to the positive infinity. So this is our graph. Alright, so this is one part. So another part at the middle here. So when x approaches -2 from the right hand side, so from the right hand side, when x approaches -2 from the right hand side, it gives you a negative infinity. It means when our graph come closer to this x equals to -2, it come to negative infinity. So means our graph will go down here. And then we have a asymptote, we have a y-intercept. Okay, so we have an intercept at y-axis. So we need to calculate when x equals to 0, what is our y-intercept. Our function here is y equals to 2x squared plus 2 over x squared minus 4. So when x equals to 0, it will equals to 2 over negative 4. So it will be negative 1 over 2. So the intersection here will be occur at negative 1 over 2. And then we move on. When graph approaches x equals to 2 from the left hand side. So we read our result when the limit approaches for the function 2 from the left hand side. So our result is going to negative infinity. So means it will come down to here. So our graph here will be going intersect at y-axis and then approaches 2 from the left hand side to the part of negative infinity. And then our last part here. When when limit approaches the function x equals to 2 from the right hand side. So from the right hand side, they will get positive infinity. So my graph will be attempt to the positive infinity, means going up here. So what happens when our function approaches infinity? So when x approaches infinity, the graph will be close to the asymptote y equals to 2. So this is an asymptote. What's I mean by asymptote? The graph will be go close to it, but does not intersect with it. So you'll go like parallel with it. So you go near to it and parallel to it. So this is our graph. So of course, our drawing will be first involving your your graph will be involving your asymptote. And then number 2, your shape of the graph. And then number 3 will be all your labeling here. So draw your vertical asymptote, horizontal asymptote, that will be your first mark. Then we go for your graph here.